So, in this final session of the course, this session about sorting 2, which you can find in the index notebook around here, and that you can see here in Google Colab, and that as usual, and because I want to avoid some annoying internet connection problems while recording this, I have downloaded to my computer. Remember that you can do that by coming to File and then Download. You can download, I recommend downloading the Jupyter Notebook because the translation of this into Python file is going to be a bit messy. Now that I am here, Jupyter Notebooks are very convenient for me for telling you about code, and they are also a good way to share code online, for example via Google Colab. Probably if you're doing applications you want to dig a little bit deeper into Python script files, .py files. We will talk about this in due time. Okay, back to our subject today. We want to be talking about sorting algorithms in our second session about this, and we will be talking mostly about two algorithms today, Mergesort and Quicksort. Those two algorithms are examples of a strategy called divide and conquer. You may have heard of this term, divide and conquer, used in many different scenarios. War games comes to mind. But this is also valid and a very widely used programming strategy. The goal is to break your problem into smaller problems that may be solvable in simpler ways. And as we will see, this has a strong relationship, a strong connection to recursive programming, of what we spoke about last time, and will be the basis, both the divide and conquer strategy and recursive programming, of both versions of the quicksort and mergesort algorithms that we will see today. Okay, let's start with some general idea about the mergesort algorithm. Here it is. Mergesort is an algorithm that receives a list of some data type that can be sorted, and we will be using integers for convenience, but we could be doing this with strings, with any data type that can be sorted. When later you learn how to code your own classes, if you give them a way to be sorted, you can also use mergesort with them. In this case we have our list of integers and we want to sort it. As you can see, it is not sorted at this moment. 5 goes before 1 and 6 goes before 3. So this is not properly sorted. We want the smaller element in the list to be here, and so on and so forth. List sorting that we have been seeing in the past few sessions. The strategy that we will use is that we will break the problem into smaller instances. Specifically, we will divide our data in the midpoint and then sort each of the sublists that we have separately. When I say sort them separately, I mean that I would have a recursive call for each of the sublists. Okay, so my merge function will be a recursive function that will have 2 recursive calls, which these 2 sublists built by breaking my original list at the halfway point, at the midpoint. Okay, this would be the recursive case of my mergesort algorithm. Okay, and if I take this data as an example, an execution of the mergesort algorithm would look something like this. I have my original data here and I divided it into 2 sublists. And what do I do with each of the two sublists? Well, I divide it again and again, okay? At the midpoint, at every point. This is the recursive the recursive case of my Mergesort algorithm. What is the base case? Well, when my list has length 1, it is already sorted, because this is a list that only contains element 5, so it is sorted. So when I reach the level where all the lists have size 1, they are all sorted. And here you can observe that I started with a list of a certain length, had lists of half that length at each step. I halved the length at each step and ended up with length 1. We have seen this before, and you can guess, I'm not going to give it too much detail in this presentation, but you can guess the height of that tree, and with that, the complexity of the Mergesort algorithm. Okay, back to it. I have divided my lists by half until I have reached lists of length 1. Now, in order to have a proper sorting algorithm, I need to combine the result of my two recursive calls, for this case, for example, and use the result in a way that gives me the correct answer for the problem that called them. In this case, I want to merge these two sorted lists into one longer sorted list. Okay, so I had the list that only contained 5 and the list that only contained 1, and this one should be merged in this way. This goes first and this goes second. In this case, the element that I had second goes second, and the element that I had first goes first. So I have to do different things to merge at every moment. Once I have reached this level, I have sorted lists of length 2, and I can merge those two to get sorted list of length 4. And merging these is a little bit more complicated, as we will see in a second. But then, once I have sorted list of length 4, I can merge them into sorted lists of length 8, which was my original goal. Okay, so I have a recursive case in this algorithm where I basically call the same function with lists half the length by dividing the list that I have at the midpoint, and then I do that until I have lists of length 1. That's my base case, having length 1, and that's already sorted so that I don't have to do much. And then to combine the results of the recursive calls into a solution for the current call, I have to merge sorted lists into a longer sorted list. Okay, that is how Mergesort works. And let's see in a little bit more detail how this merging thing would work. I have started at the last step because it's a little bit easier, and we can see a couple of important details. And I have two lists of length 4 that are sorted, and I want to combine them into one list of length 8 that's also sorted. And what I will do is very simple. I'm going to consider the two lists to be sorted, and I'm going to be using a pointer in each list to the first element that I have not yet visited in this list. So these two pointers will advance in order and will advance in order as I visit elements, and they will help me access the elements in order because these two lists are already sorted. I need an output list where I will put the correct final output, and this one also will have a pointer that will help me know how far along I am. What will I do in each step? Well, I would look at the pointed elements in each list and see which one is smaller. I have to choose the smallest element pointed. In this case, between 1 and 3, it's 1. Okay, so this guy is going to be the smallest element. I'm going to put it here. And now I'm going to move the appropriate pointers. Which ones? Well, this one is pointing to the first element not yet sort it in the output list, so this one should go here. I have already visited 1, so I should move this pointer here. And 3, I have visited it, but I have not yet put it in the output, so this one stays here. Okay, and now I just iterate this process. Okay, well, maybe this was a little fast, but I'm going to check 2 and 3, and I'm going to see that the smallest is 2, so I'm going to put 2 here, advance this one, advance this one. See? Again, which one is smaller between these two? Well, now it's 3, so I'm going to put 3 here, advance this pointer, and advance this pointer. And so on and so forth. Okay? Next one between 6 and 4 is 4, so 4 comes here. Between 5 and 6 is 5. So, I have reached the end of one of my sublists. If I do that, then I can just put the rest of the output. This was already sorted because I had a recursive call that ensured that, so I can just put all these elements here and I'm done. Okay, I'm not going to give you the code for the Mergesort function in Python. You can for sure find it on the internet, absolutely no problem. But I encourage you to try to use your amazing ability in recursive algorithms and in sorting algorithms to try to code that yourselves. In the next explanation in this session, I'm going to be talking about quicksort, and I'm going to give the whole code for that one. After I have done that, I will say a couple of words about the sorting problem, as we have seen quite a lot of sorting algorithms, and then we will be finished with the course.